I'm Lorenzo Papale, as I mentioned before in the round table, and I'm an environmental engineer and a PhD student in Geoinformation at Vergata University of Rome. And my PhD activities can be summarized by three main concepts, which are Earth observation, machine learning, and traditional modeling. I'm trying to match these three concepts to work on physics-based machine learning for Earth observation applications. And concerning my main activities, the activities related to my PhD project, I'm trying to implement a physics-based machine learning for soil moisture estimation using polarimetric SAR data. And in order to do this, I started with the Vergata fully polarimetric scattering model for maize that is able to simulate the total backscatter, but also its components. So the main canonical scattering mechanism, the volume, the double bounce, and the multiple scattering when the maize plant grows. And I have extracted these components, but also the total scattering covariance metrics to train a machine learning algorithm, in particular an artificial neural network, to extract from the total scattering covariance metrics the soil-related backscatter components. So the backscatter related to the soil, but also the backscatter related to the double bounce, since in the double bounce mechanism, the soil is strictly involved. So I trained this machine learning algorithm, and in these weeks, I'm testing the results on simulated data. But the real goal is to apply this model to real polarimetric SAR data. So I will try to apply this physics-based machine learning algorithm since it is trained with the simulated data from the electromagnetic model, but to test and use this model to real polarimetric SAR data in order to estimate the soil moisture, not from the total backscatter, but just from the components related to the soil, to avoid the vegetation influence. So concerning the other activities, I'm involved in the Clexidra project, in which we have some on-site measurements, very similar to the measurements of the previous presenter. SAR data in L-band, in particular SAUCOM data, and also the model I mentioned before. With the usage also of machine learning algorithms, we want to analyze the geophysical parameters and their influence in the SAR backscatter. With EOLO, with this project, we have also in this case on-site measurements, SAR data, in this case Sentinel-1 data, so C-band, and we process this data in a machine learning algorithm to estimate soil moisture estimation in order to provide to farmers an irrigation advice. And then I'm involved in the UMetNet project, which is a project held by the Italian Air Force Meteorological Service. In this project, we combine modeling predictors coming from traditional modeling and radar and satellite data in a machine learning algorithm, basically in a decision tree algorithm to detect thunderstorms for thunderstorm forecasting. So these are my activities, and thank you for your attention.